Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2021, Paper 2, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1a. How many sides does a pentagon have? Well, this is simply a knowledge question, isn't it really? You need to know the names of your common polygons. Pentagon is the 5-sided one, so it's got 5 sides. Part B says, write down the mathematical name of this solid. We call this one a cone, isn't it? In actual fact, a cone is a circular pyramid, or a circle-based pyramid, I suppose. So if you write that down as well, you probably get the mark too, but the proper name for it is a cone. Part C says the angles in a triangle are 40, 50 and 90. Write down the mathematical name of this type of triangle. Well, any triangle that has got a right angle in it, like this one does, 40, 50 and 90, we call those right angle triangles, don't we? So that is what it is. Right angled triangle. The other ones you need to know are scalene. That's the one where all the sides are different. So you could say that this was a scalene triangle as well. So scalene is the other name for it. So that's a triangle where all 3 sides are different. And then you've got isosceles where 2 sides are the same, and equilateral where they are all the same. So you need to know all those names. Question 2. Work out -7 plus 10. Now if you struggle with negative numbers, and lots of students do, it's well worth spending a minute or two drawing out a number line somewhere on your exam paper. And then you can use that for the rest of the paper. If you write it somewhere on the back page or somewhere, then you can go and use it wherever you've got some negative numbers to add or subtract. So here I've got -7 plus 10. So if I'm starting at -7 on the number line, here I am here, and I'm going to go up 10 jumps. Plus is to the right, isn't it? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Takes me to 3. So my answer is 3. 4 times -2. Now when you're multiplying positive and negative numbers, you just go ahead and multiply the numbers. 4 times 2, that's going to be 8. And then you have to think about what the sign is going to be. Now here I've got 1 positive and 1 negative, and a positive times a negative is negative. Okay, so if the signs are different, it's going to be negative. If the signs are the same, either both positive or both negative, your answer ends up being positive. Okay, but yeah, you know, if negative numbers aren't your thing, just spend 2 minutes drawing out a number line. It won't kill you, and it might help you gain another extra couple of marks on the paper. Right, let's move on. Question 3, work out 9.06 divided by 3. I'm going to do this by short division. So I'm going to put the divisor on the outside and the thing I want to divide under the bus shelter like that. And I'm going to say, well, how many times does 3 go into 9? It goes in 3 times. How many times does 3 go into 0? It goes in 0 times. How many times does 3 go into 6? It goes in 2 times. Now the decimal point there started after the 9. It's going to be in the same position in the answer. So my answer is 3.02. 15 times 0.6. Well, 0.6. Well, if I was doing 15 times 6, then 10 sixes would be 60 and 5 sixes would be 30. So together that would give me 90 then, wouldn't it? So if 15 times 6 is 90, then 15 times 0.6, which is 10 times smaller, my answer is going to be 10 times smaller as well. It's going to be 9, isn't it? So my answer is 9. Question 4. Use one of these symbols, less than, greater than, or equal to make these statements true. So A, I've got 1/4 and 0.025. So which one is bigger? Well, what's 1/4 as a decimal? 1/4. To make it a decimal, I need to make it either a fraction over 10 or a fraction over 100. Now 4 doesn't go neatly into 10, does it? But if I multiply it by 25, I do get 100, don't I? So multiplying top and bottom by 25, then that gives me 25 over 100, which means that 1/4 is 0.25. So is 0.25 bigger than 0.025? Oh yes it is. So that's the largest one then, isn't it? 0.304 versus 0.34. Now when you're comparing decimals, start on the outside and work your way in. So compare like with like. So they're the same. They're the same. And then the next digit along, I've got a 0 here and I've got a 4 there. So the one on the right is definitely bigger than the one on the left. So the sign goes that way around. 0.34 is bigger than 0.304. Okay. Question 5a, work out 4 plus 16 divided by 2. Well, we've got an order of operations question here. Need to be thinking about BIDMAS, brackets, indices, division and multiplication, addition, subtraction. So we've got some division here, there, and we've got some addition. Now addition comes after division, doesn't it? So we're going to have to do the dividing first. So dividing 16 by 2, 16 divided by 2 is 8. So that means I got 4 plus 8, and then I'm going to add those together then, and that's going to give me 12. Okay, so the answer is 12. The second one, insert one pair of brackets to make this calculation correct. Okay, so I'm aiming for 4. I'm looking at that divide by 9 on the end. So if I'm going to divide by 9 and get a nice number, then the thing that I need to divide has got to be a multiple of 9. So 1 is by itself is not a multiple of 9. If I add 7 to it, I'm going to get 8. And even if I times that by 5, it's not going to be a multiple of 9. What about if I multiply 5 and 7 first? That gives me 35. And if I then add 1, that's going to give me 36. So I think that's the way we're going to have to do it. Let's put brackets around this part then. So normally, BIDMAS would say do the multiplying first. So that would naturally come first. And then it would add on the 1. So 5 times 7 would be 35, plus 1 is 36. That means the contents of the bracket will be 36. And then when I divide 36 by 9, I'll get 4. Okay, so that seems to work. Question 6. In the quiz, Darcy answered 16 of the 20 questions correctly. What fraction of the questions did Darcy answer correctly? Give your fraction in its lowest terms. Okay, so we've got 16 out of 20. So writing that as a fraction, that is 16 out of 20, like that. So that number he scored is on the top, and however many it was out of is on the bottom. Okay. Now remember, we need to write this in its lowest terms though, and it currently isn't in its lowest terms because 16 and 20 have some common divisors. They're both in the 4 times table, so I can divide them both by 4. 16 divided by 4 is going to give me 4. 20 divided by 4, that's going to give me 5. Now, can I cancel that down anymore? No, I don't think so. 5 is prime, so it's only got factors 1 and 5. And other than 1, we're not going to divide 4 by anything that matches dividing 5. So that's as far as I'm going to get. So 4/5 is my final answer. Right, and then part B says write this fraction as a decimal. Now, I said earlier to write a fraction as a decimal, what you want to do is make it either a fraction over 10 or 100 or 1,000 or so on. Now, I can make this simply into a fraction over 10 just by doubling 5, can't I? So if I times 5 by 2, I get 10. Doing the same thing on the top, I'm going to get 4 times 2, that's 8. So 4/5 is 8/10, and 8/10 then as a decimal is just 0.8. Because you know, that's tenths, isn't it? The number after the decimal point is just tenths. So if I've got 8/10, then I can just write it as 8/10 like that as a decimal. More fractions in question 7. Hope you're getting on with your fractions, otherwise you're going to struggle in this paper, aren't you? So part A says write 13/3 as a mixed number. Now when you're converting a top-heavy or an improper fraction into a mixed number, an improper top-heavy means this number is bigger than this one down here, isn't it? So the number on the top is bigger. So we just need to work out how many times 3 goes into 13. So how many times does 3 goes into 13? 3, 6, 9, 12. It goes in 4 times. Okay, so the number of times it goes in is the large number, the whole number part. The remainder, when you divide 13 by 3, 3 goes into 13 4 times, remainder 1, doesn't it? So whatever the remainder is, that becomes your numerator of the fractional part of your mixed number. And the denominator is the same as it was before. Because it was 3, it's still 3. Okay, so the answer then is 4 1/3. Okay, now part B says work out 1/3 plus 4/9. Now you can only add fractions together when the denominators are equal. Currently they're not. But if you can see that 3 times 3 is 9, isn't it? So I can easily make the first fraction equal to 9ths by multiplying top and bottom by 3. So 3 times 1 is 3, and 3 times 3 is 9. So 1/3 is the same thing as 3/9. 4/9 can stay as is, and once I've got the denominators the same, I can just go ahead and add the numerators. So 3 plus 4, that's 7. That's 7/9 altogether. Okay, and then finally I've got 3 divided by 1/3. Now when you divide by a fraction, there's a handy way of remembering it. It's KCF, keep, change, flip. So that's what we're going to do. We're going to keep the first number the same, although I'm going to rewrite it as a fraction. So rather than just writing 3, I'm going to write it as 3/1. Change the sign, so from a divide to a times, and then flip the second fraction over. So my 1/3 becomes 3/1. So then we can do the multiplying. 3 times 3 is 9. 1 times 1 is 1. So that's 9/1, or that's just 9 altogether then, isn't it? So that's my final answer, 9. Question 8, here is a function. I've got an input, and when it goes into the function machine, 3 is added, and then from that, it's all multiplied by 7, and I get the output. So part A says find the output when the input is 2. So if I take this 2 here and I feed it into the function machine, so 2 goes in, I'm going to add 3 to it. 2 plus 3 is 5. So after the first part of the function machine, I'm going to get 5. And then that 5 is fed into the second step of the function machine where it's multiplied by 7. 5 times 7, that's 35, isn't it? So the output when input is 2 is going to be 35. Okay. Find the input when the output is 63. Okay, so we're going to be working backwards in this case. So if the output is 63, then what would it have to be here so that when I times it by 7, it's 63? Well, I know that 9 times 7 is 63. So I must have had 9 at this point here, so that when I times it by 7, I got 63. And if I've got 9 here, and I had a number and added 3 to it, and I got 9, then working backwards, 9 take away 3, that's 6 then. So 6 would have had to go in, so that when I add 3, I get 9, and then when I times by 7, I get 63. So find the input when the output is 63. The input must have been 6. Question 9. A shopper buys 4 apples costing 60p each and 3 peaches. They pay with a £5 note and receive 44p in change. Each peach costs the same amount. Work out the cost of 1 peach. You must show your working. Okay? Okay, so we know everything in this apart from the cost of the peaches. Now this is actually an algebra question. So I'm going to say the cost of a peach equals P. I'm going to use P. P for peach. Okay, so a shopper buys 4 apples costing 60p. So 4 times 60 and 3 peaches plus 3p. They pay with a £5 note and receive 44p change. So that's equal to £500 minus the 44. Okay, so that's what we're told in that sentence. 4 lots of 60p plus 3p equals 500 minus 44. Okay, so let's just kind of tidy that up a little bit. 4 times 60, that's 240, isn't it? So 240 plus 3p is equal to 500 minus 44. What's 500 minus 44? 500 minus 44. 0 take away 4, I can't, so I'm going to borrow 1 from there. 4 gives me 10. I'm going to borrow 1 from there, gives me 9 and 10 there. So 10 take away 4 is 6. 9 take away 4 is 5. And then I'm going to have a 4 on the end then. So 456. So 4, 5, 6. So 240 plus 3p equals 456. Okay, so then taking 240 away from both sides. What's that then? So that's going to give me 6 take away 0 is 6, 5 take away 4 is 1, 4 take away 2 is 2, 216. And then that's going to be equal to 3p then. So if I want p, I'm going to have to divide that by 3 then, aren't I, both sides? Okay, so what's p then? Well, what is 3 into 216? 3 into 2 doesn't go. 3 into 21 goes 7 times, and then 3's into 6 go twice, so that's 72. Okay, so that tells me the cost of a peach is 72p. Question 10. Ben and Sundip are making pancakes using the ingredients below. Ingredients to make 12 pancakes: 75 milliliters of water, 200 milliliters of milk, 100 grams of flour, 50 grams of butter, and 2 eggs. Now the ratio of the amount of water to the amount of milk needs to be 75 to 200. Write this ratio in its simplest form. So if I've got a ratio of 75 to 200, these cancel down pretty much the same way as fractions do. You've got to look for common divisors that you can divide through by. Now I know that 75 and 200 are both divisible by 25. So if I divide both sides by 25, if you don't spot 25, you might spot 5 and then do it a second time to cancel it down a bit more. But I could see that 75 had 25 in it, so yeah, I could do it straight away. So 25s into 75 go 3 times. You've got 4 25s and 100, so you're going to have 8 and 200. So that cancels down to 3 to 8. Okay, so I think that's in its simplest form. 3 is prime, and it doesn't go into 8, so 3 to 8 is our simplest form. Part B says Ben makes 18 pancakes. Work out how much flour he needs. Okay, well, if I make a ratio of pancakes to flour, then I know from the original recipe that for 12 pancakes we needed 100 grams of flour. So I can write down 12 to 100 here. Okay, now what I want to do is change 12 pancakes to 18 pancakes. Now I can't just multiply 12 by something to get 18, okay, but I can go by a stepping stone to make the maths a little bit easier. So if I first find out how much it is to make 6 by dividing by 2, I can then scale that up by a factor of 3 to find 18. I think that's going to work easier with my 100 on the other side, isn't it? So on the other side, if I divide 100 by 2, I'm going to get 50. So for 6 pancakes, I need 50 grams of flour. And then taking that 50 and scaling up by a factor of 3, then 50 times 3, that's 150. So for 18 pancakes, I need 150 grams of flour. Okay, then Sundip has 225 grams of butter and 10 eggs. She has plenty of the other ingredients. Work out the maximum number of pancakes that she can make. So which one is going to be the limiting factor? Is she going to be more limited by the amount of butter, or is she going to be more limited by the amount of eggs? Okay, well, At the moment, we know that pancakes to eggs is 12 pancakes for 2 eggs. So then if I wanted to, if I have 10 eggs, that's 5 times as many as that, isn't it? Okay, so 5 times 12, that gives me 60. So I've got enough eggs to make 60 pancakes. But that might not be the limiting factor. I might be limited on the butter. So let's just double check the butter as well. So for the butter, we've got 12 pancakes it requires 50 grams of butter, and we've got 225 grams. Okay, so again, it might be helpful to go by a stepping stone, because 50 doesn't go directly into 225. But if I halve it first to get 25, then I can easily scale it up to 225 after that. So dividing 50 by 2 will tell me how much pancakes I can make with 25 grams of flour. So that's 6, isn't it? I can make 6 pancakes if I divide 12 by 2. I'm going to get 6. And then taking 25 and scaling it up, how many 25s go into 225? Well, it's going to be 4, 8, 9 times, isn't it? So I times that by 9. I should know that gives me 225. So doing times it by 9 on the other side, 6 times 9, that's 54. Okay, so I've got enough eggs to make 60 pancakes, but I've only got enough butter to make 54. So that's going to be the limiting one, isn't it? You know, I've got enough. If I've got enough eggs to make 60, then I've got enough eggs to make 54. But if I've only got enough butter to make 54, then I don't have enough butter to make 60. So 54 is the maximum I can make then, isn't it? So 54. Question 11. Ali, Blake, Rowan and Sam are in a relay team. Sam always runs 4th in the team. The order of the other 3 is chosen at random. Complete this table to show all the possible orders for the team. The first row has been completed for you. You may not need to use all the rows. Okay, so there's not definitely enough to fill out that table. Okay, so I know that I'm going to have S in the last column for everything because Sam always goes last. So I need to find all the various combinations of the first 3, then haven't I? I'm going to be systematic about that. I'm going to keep the first one the same and switch the other 2 first. So it could be A, B, R and then S, or it could be A, R, B and then S. Okay, so they were all the possibilities with A coming first. Then what are the possibilities with B coming first? I could get B, A, R, S, or I could have B, R, A, S, just switching the R and the A around, or R could come first, so in which case I'd have R, A, B, S, or I'd have R, B, A, S. Now I think that's all the different options. I don't think there are any more. Okay, S is in the same in all of them, and I've switched out all the others into every position they can possibly be. Part B says find the probability that Ali will run first. Well, probability of Ali first. Now, any probability is successful outcomes over total outcomes. That's kind of the formula. So in this case, how many successful outcomes are there? How many outcomes are there with A first? Well, it's those 2, isn't it? There's 2 of them. So there are 2 outcomes where A comes in first. And how many outcomes are there altogether? Well, there's 1, 2, 3, 4, 5, 6 altogether, aren't there? So there's 6 different outcomes altogether. So the probability that Ali will run first is 2/6. Now you can cancel that down to 1/3, but you're not going to get any extra credit for it. So I'm just going to write it down as it is. Question 12. The shape below is formed by a rectangle of width 4 centimeters and a regular pentagon. For the rectangle, the ratio of width to length is 2:5. Work out the perimeter of the shape. Okay. Well, this is a regular pentagon, and regular means that all the sides are the same, doesn't it? So we know that that side is 4, so that's going to be 4, that's going to be 4, that's going to be 4, that's going to be 4. Okay, and I know that the opposite side of a rectangle is the same as this one, so that's also 4. All we've got to do really now is work out this length here, isn't it? Now I know that the ratio of the width to the length is 2 to 5. So I just need to make this one 4 then, so which matches with its actual length, and then I'll know the length of the other side. So to go from 2 to 4, well, that's doubling, isn't it? That's twice as big. So doing the same on the other side, that means that my other length must be 10. So that means this is 10 and this is 10. Okay, so now I've got all the edges of this shape. I can just simply add them up to find the perimeter then, can't I? So then the perimeter, just going to start in one corner. Let's start here and work our way around the shape. So I'm going to get 10 plus 4 plus 10, going from here, 10 plus 4 plus 10. And then I'm going to have 4 plus 4 plus 4 plus 4. Plus 4 plus 4 plus 4 plus 4. Okay, what's that add up to? So altogether I've got 5 4s, adds up to 20, plus the 2 10s is going to give me 40 then, isn't it? So the perimeter of this shape is going to be 40 centimeters. Question 13, part A. Reese is given this question. Write 20 as a product of prime factors. Give your answer in index form. Reese's answer is 2 times 2 times 5. Is Reese correct? Explain your answer. I think that looks all right to me. Now to find products of prime factors, you just do your number and think of two numbers that multiply together to give you a number. So what, 20 is 4 times 5. If it's prime, you stop. If it's not prime, you carry on. So what multiplies together to give me 4? It's 2 and 2. Okay. Now when you get to all primes, you stop. So I can see that 2 times 2 times 5 is indeed the correct prime factors for 20. So 20 is equal to 2 times 2 times 5. But this is not in index form, is it? Index form means showing it as powers. So this is actually 2 squared times 5 in index form. So I can say, I think I might write that down. I might just say this is not in index form. Not in index form. Okay, so it's not in index form, and I put it in index form. I think that's pretty good. Pretty good answer. Right, part B says complete the power of 2. 1/8 is 2 to the what? Okay. Well, if you think about it, 8 is 2 cubed, isn't it? Okay. So 1/8 is going to be the negative reciprocal of 8. So that's going to be 2 to the minus 3. It's going to have a negative index. So a negative index means 1 over that thing with a positive index. Okay, so I'm going to say that it's 2 to the minus 3 there. Okay, finally I've got root 81 times 2 cubed. What's that then? Well, the square root of 81 is 9, so that's going to be equal to 9. And 2 cubed, well, 2 times 2 times 2 is 8. And 9 times 8, well, that is 72, isn't it? So that's my final answer there. 9 times 8 is 72. Job done. A car mechanic has a tin containing 5 litres of engine oil. Each week they use 450 millilitres of this oil for their vehicles. The car mechanic says, after 9 weeks, I will have used over 80% of the oil in this tin. Are they correct? Show how you decide. Okay. So, first up, we've got 5 litres in the tin to start with. Now, each week we are consuming 450 millilitres of oil. Now notice the mixed units here. So the first thing I'm going to do is convert everything into the same unit. Now I think it's going to be easier to convert 5 litres into millilitres. Now 1 litre is 1,000 millilitres. So 5 litres is going to be 5,000 millilitres. So that's my starting amount of oil. Okay. Right, so the car mechanic is saying that after 9 weeks, he's used over 80% of the oil in a tin. Okay, so if he's spending 450 millilitres of oil a week, and after 9 weeks, how much oil is that altogether? I think that's what we need to find out. I'm going to work out total oil consumed. And that's going to be the 450 milliliters of oil that is consumed each week times by the number of weeks, which is 9. Okay? Now, 450 times 9. Now, I know that 450 times 10 is going to be 4,500. So times 9 is going to be 450 less than that. So 4,500 take away 450. That's 4,050. Okay? Now, if you're struggling with that, then you could always, you can do it by long multiplication and work it out that way. Okay, but I was just doing 450 times 10 is 4,500. Take one of the 450s away. Going to be quicker than doing that multiplication. Okay, so anyway, that's 4,050 used. Now, is that over 80%? So that's the total oil consumed. Percentage consumed. That's going to be the amount of oil that we used up divided by the total amount of oil. Okay, so is that going to be more than 80%? Okay, now to get that, I think what we need to do is convert this into a fraction over 100, so we can rewrite it as a percentage. Well, I can see that I can scratch a 0 off the end there straight away, top and bottom. So that's going to give me 405 over 500. And then if I can divide top and bottom by 5, then I'm going to get a fraction over 100, then, aren't I? So if I just say that's the same thing as 405 over 500, and then if I can divide top and bottom by 5, I'm going to get a fraction over 100, then, aren't I? Okay? So I don't know what the numerator is yet, but I know 500 divided by 5 is 100, so that's what I'm aiming to do. So what is 405 over divided by 5? Let's just do this over here. So 5s into 405, 5s into 4 don't go, 5 into 40, that goes 8 times, remainder 0, and 5s into 5 go once. So that goes in 81 times. So 405 divided by 5, that is 81. So 81 over 100, what is that as a percentage? That is 81% then, because it's over 100, that's what a percent is. So that's 81%. So after 9 weeks, I have used over 80% of the oil in this tin, said the mechanic. Is the mechanic correct? Yes, we've used 81%, which is over 80%. So I can say 81% is greater than 80%, so the mechanic is correct. Okay, so we've interpreted the answer. We haven't just worked out the answer is 81. We've interpreted that answer. We've said 81 is greater than 80, and then we've concluded that the mechanic is correct, and that will earn us all the marks. Question 15, solve the inequality 2 lots of x plus 5 is less than 16. Now, don't panic when you see the word inequality. These solve exactly the same way as equations. So as long as you can solve equations, you can also solve inequalities. Okay? Now, normally, when you have a bracket like this, students' first reaction is to try and multiply them out. But that's not always the best thing to do. Now, especially if this number here divides into the number at the back. If it does, then it's much better just to divide by that number to start with. So rather than multiplying out the brackets, 2 lots of x, 2 lots of 5, and then looking to simplify, much better just to divide both sides by 2 to start with. I'll show you what happens. If I divide both sides by 2, that's going to cancel, and it's immediately going to get me down to x plus 5 is less than 8. Okay, so I'm just one step away from solving it now. So if I subtract 5 from both sides, that's going to leave me with x is equal to, oh sorry, not x is equal to, x is less than 8 take away 5, that's 3, isn't it? And that's my solution. X is less than 3. Okay, so they just work the same way as equations, but I've just got like a less than sign running through it rather than equal sign. And just take note that it's sometimes quicker to divide by the number outside a bracket rather than multiplying it out when you're solving equations and inequalities. Here are sketches of 5 graphs, 5 very interesting looking graphs there. Write the letter of the graphs that represent the following relationships. The first one, y is directly proportional to x. Now, direct proportional means that if x doubles, then y doubles. Okay, so when you plot these on a graph, you're going to get a straight line that passes through the origin. Okay, so it has to be a straight line, so that makes it either B, E, or C, but it has to go through the origin, and there's only one that goes through the origin, and that is C. Now, it has to go through the origin, otherwise if you double one, you're not going to double the other. You might double it and add a bit more on. So yeah, it has to be C. Now, inverse proportion, inverse proportional is 1 over x, isn't it? Or 1 over your value. And the graph y equals 1 over x we call the reciprocal curve. Often when we need to plot it, it has two parts like this and this, but in this case we're just looking at the section up here in the first quadrant, aren't we? That's going to be graph D. So it is D. D is y is inversely proportional to x. Question 17. The diagram shows a prism, and part A says draw an accurate plan view of the prism on the 1 centimeter square grid below. Now we'll do the proper grid for in a minute. Let's just think it through. Now this topic is called plans and elevations, and you need to know how to construct or find the various two-dimensional views that you can make from this three-dimensional shape. So often you're asked about the front elevation, which is looking at your shape from this direction, or sometimes you're asked for the side elevation, looking at it from this direction, or the plan view is what we're being asked to do today, is like the bird's eye view of your shape, looking down at it from above. Okay, so when you look down at your shape from above, you're just going to see the two rectangles next to each other. Okay, it's not going to be clear that this bit in the middle is higher up than the other two. So when you're looking down from a bird's eye view, you'll just see like one part of the root slope in one way as a rectangle, and the other one as a rectangle as well. Okay, now the distance you'll see is going to be so for this distance here, you're not going to see this distance of it, because you're just going to see this bit along the base, this much of it. Okay, so that distance there is going to be 4, and again for this bit here you're going to see this part from above, which is 6 take away 4, that's 2, isn't it? So that's going to be 2. This distance 8 is going to be this distance here, so that's going to be 8 along this side, and then we're done, aren't we? So don't really need the 5, and the other side of the rectangle is the same. So it's going to be 2, 4, and 8. They're the dimensions that we're going to have to use here. Okay, so looking at your shape down here, you're going to have a rectangle which is 8 units high, 8 in that direction. Then we're going to have another 8 here, so that's going to be the first part of my roof, and then 4 more squares along. We're going to get the second line, aren't we, or the third line of the roof. So this bit on here, look, this bit here, this is this part of the roof from above, and this part is this side of the triangle here that you can't see. If I was gonna show you the kind of, this is a wireframe, then it would be that part of the roof there, wouldn't it? Okay, that's the bit you're seeing on the left hand side. Okay, so that's kind of what it looks like. There's two rectangles next to each other, 2 and 4 and 8. Part B says show the volume of the prism is 72 cubic centimeters. Okay, well, you no doubt know that the volume of a prism is equal to its cross-sectional area multiplied by the length or the height between its kind of front and back matching face. Okay, so in order to work out the volume of this prism, we're going to have to work out the area of that cross-section there. That's the cross-section. We need to know that. And we need to then multiply it by that distance between its front and the back face, that 8 there. Okay, so that front face there, the cross-sectional area is a triangle. So the area of that triangle, that's going to be a half base times height, isn't it? That's the formula for a triangle. So the base is 4 and the height is, no, the base is 6, isn't it? Sorry. The base goes all the way across there, so the base is 6. So that's a half times 6 times a height of 3. So I tend to cancel that half into whatever number is even over here. So half of 6 is 3, and then 3 times 3, that's 9 then, isn't it? So that's 9 centimeters squared for the area. And so the volume is going to be that 9 centimeters multiply the distance between the front and the back face, which we said was 8. 9/8, that's 72 centimeters cubed as required. Okay? And then part C says a cuboid with a square base also has a volume of 72 centimeters. The height of the cuboid is 2 centimeters. Work out the length of one of the square bases. Okay, so we've got like a diddy short cuboid, which has got a height of 2, and it's got a volume. And it's a square at the top, so whatever that length is there, then that's also going to be the length there then, isn't it? So the volume of a cuboid is length times width times height, which in this case is going to be our matching lengths because it is a square-based cuboid times its height of 2. So that's going to be 2 lots of L squared basically. And we know then that the volume of this is 72. So we can say then that that is equal to, so 2 lots of L squared is equal to 72. Dividing both sides by 2, I'm going to get L squared is equal to 36. So then L is going to be the root of 36, isn't it? And what's the square root of 36? It is going to be 6. L is 6 is the final answer. Okay, so it's going to be a 6 by 6 by 2 cuboid. 6 times 6 is 36 times 2 is 72. Seems to work. Happy with that. Let's move on. Question 18. The table shows the marks obtained by 10 students in spelling tests in January and February. And we've got various students and their scores in the table there. And then the marks of the first 6 students are plotted on the scatter graph. And part A says plot the marks for the remaining 4 students. Okay, so the shaded ones are already on the diagram. We need to add those other ones on as well. So you can see you've got January along the bottom and February up the side. So the first one is going to be 70, 86. So I'm going to read across to 70 and then up from there to 86 for my mark. So, a bit hard to read on my computer screen, but it's around about there. Okay, you're only given like a half square tolerance on these, so you really need to try and get them bang on. Okay, next one is at 4460. So 1, 2, 3, 4, 4460. I think is there. And then 3738. 3738 is around about there. And finally, also it's 3748. 3738, which is, sorry, 48, which is here. And what's the last one? 3850. 3850. So there. Okay. So I've added my 4 extra points on. Describe the type of correlation shown in the completed scatter diagram. Well, you could see that all of the points are kind of pretty much in a straight line running up the middle, bar one that's a little bit off to the side. Okay, so if I was going to draw a line of best fit through this, I would be drawing a line something like that through them. Can you see? That's kind of going through most of my points. And that's clearly going in an upward direction. So we call a line sloping upwards from left to right positive correlation. So as one increases, so does the other. Part C, on the scatter diagram, circle the student that made the greatest improvement in their mark from January to February. Now that's going to be this outlier over here. Okay, can you see he's quite low in his January score, but he's well up in the February score. So he's the one highest above the line of best fit, furthest away from the line of best fit. So yeah, he's done the best or the most improved from one to the other. And then finally it says work out the percentage change in this student's mark from January to February. Okay, so what is his January score? His January score is 30, and his February score, what's that? That's 66. So work out the percentage change from January to February. So then that's 66 over 30. What's 66 over 30 then? I'm going to try and get this as like a fraction over 100, so we could kind of read it as a percentage. So if we kind of divide that top and bottom by 3 first, so divide by 3, divide by 3. The reason for that is then I'm going to get 22 over 10, and then that allows me to scale up nicely to 100 by multiplying through them by 10. Okay, so then that's 220 over 100. Okay, which is 220%. Now, it doesn't mean it's gone up by 220%, because if you consider 30 to be 100%, then if he's now at 220%, he's gone up by 120%. So you always start with 100. So 100 to 220 is the increase of 120%. So that is 120% increase. Okay, because yeah, you started with 100. Part D says another student, Kai, scored 79 marks in the test in January but was absent for the test in February. Kai says, I could use the line of best fit on the scatter diagram to estimate the marks I may have achieved in the test in February. Is Kai's method reliable? Give a reason for your answer. Now, normally with that's how you do use a line of best fit, isn't it? So if you've got a line of best fit, so you've got some points and you've got a line of best fit, then if you look up from one, then you can read across and estimate what the other one is going to be. Okay, but if it's beyond the range of your data, so we had scores from the first test going from between, I think it's 24 up to 70, off the top of my head. I don't want to go back and look. So I knew it was, the top one was 70. Now if we're looking at 79, we're looking beyond the last value of our data. Okay, so if you look up within your data range, we call that interpolation, and that tends to be fairly reliable. But if you look up beyond the end of your data, that's called extrapolation, and that is not reliable. Okay, so I'm going to say not reliable. Kai would be extrapolating, as 79 is beyond the range of his data, which is, what was it, 24 to 70? Something like that. That's a very thorough answer for a 1-mark question. But yeah, I like to be thorough. So it's not reliable. Kai would be extrapolating as 79 is beyond the range of his data. Actually, I think it was 26. Better make it accurate. 26 to 70 is the range of data we've been given. A worker received a 10% pay increase in 2017 and a further 10% pay increase in 2018. The worker says, over these 2 years, my pay increased by 10% plus 10%, that's 20%. Is the worker correct? Work out the correct percentage increase, you must show your working. Well, I can tell you right off that it isn't correct, because this is an example of compound interest, where you kind of, if you add a percentage increase to something and then add another percentage increase, you're not only increasing the original value, you're also increasing the bit you added in the first increase. So the net result is it's slightly more than adding the two values together. Okay, and that's what the compounding effect is of compound interest. So in order to work it out, we could just take a value and work out what that is, because it doesn't say what the amount is. So Assume value is £100, say. Okay, so if we had £100 and we increase that by 10%, so in 2017 we're adding 10%, aren't we? So we're gonna add 10%, £100 plus 10%. 10% of 100, that is 10, isn't it? So 100 plus 10, that's going to be £110, isn't it? So at the end of 2017, you've got £110. And then in 2018, that's going to be my £110 plus 10%. 10% of 110, that's 11, isn't it? Okay, so then that gives me 110 plus 11, that is £121. Okay, so you're going to get £121 at the end of 2018. So what is the actual increase? So again, final original multiplier, FOM. So the final is what we got at the end of it. That's £121. So that's going there. The original is what we started with. We assumed it was 100. The multiplier is what we're trying to work out, isn't it? That's what we're trying to find. So let's cover up the thing we want to find, the M, and then the multiplier then. That is equal to the final over the original, according to my triangle, which is 121 over 100, which as a percentage you can see is just 121%, isn't it? Now we had the same conversation earlier that 121%, if it's 121%, that is an increase of 21% then, isn't it? Because you always start with 100%, so 100% taken off 121 leaves you at 21% it's gone up by. So 10% plus 10% is actually equal to 21% when you're talking about compound interest. Force is measured in newtons, abbreviated with the letter N. A force of 198.5 newtons is applied to a rectangular surface of length 4.9 centimeters and width 4.1 centimeters. Work out an estimate of the pressure in newtons per square centimeter applied to this rectangular surface. And in brackets it says the formula for pressure is pressure equals force divided by area. Okay, now the key word to this, and the one that the examiners have even bolded for you, is this word here, estimate. And this has a very specific meaning in maths. It means you need to round all your digits off to, or all your numbers off to one significant figure. Okay, so I'm going to do that. So the force is 198.5, which is to one significant figure. This is the first significant figure here, isn't it? It's the 1. So I'm going to round off after the 1. The next digit is a 2, so that means I need to... the next digit is a 9, that means I need to round that 1 up to a 2. So I'm going to get 200 newtons to one significant figure. Another way of thinking about it is that 1 is in the hundreds, so you're rounding it to the nearest 100. Okay. The length of the shape is 4.9 centimeters, and that rounds off to one significant figure. This is the first significant figure here, the 4. The next digit is a 9, so we're going to round up again. That one rounds up to 5 centimeters to one significant figure. And then finally width. We're given that as 4.1, and if I round that off to one significant figure, then the one significant figure is that, the first significant figure is that 4. So the next digit is 1. In this case, we're going to round down, isn't it? So that's 4 centimeters. Okay. So then pressure, the values I'm going to, they're the values I'm going to use in this formula then, isn't it? So pressure is force over area. Well, the force is easy enough. It's just 200. The area is pretty easy as well because it's a rectangle, isn't it? So area equals length times width, which is 5 times 4. That's 20. That was a bit of a scrawl. Let's just write that again. A length times width. which is 5 times 4, which is 20. So I'm going to be dividing 200 by 20. So cancel, that's 20 divided by 2. That's 10, isn't it? So that's 10 what? Newtons per square centimetre. Okay, that's 10. Question 21a, complete this table for y equals x squared minus 3. Okay, so we've got to find two values for y when x is 0, when x is minus 3. So when x is 0, then y is going to be 0 squared minus 3, isn't it? And that's equal to minus 3. So that goes in the table there. When x is minus 3, then y is going to be equal to negative 3 squared minus 3. Now, negative 3 squared, negative times negative is positive, so that's going to be 9 subtract 3, which is going to give me the answer of 6. So that one there is going to be a 6. Okay? Now, you should note that these graphs are vaguely symmetrical around the middle, aren't they? Because they're parabolas. And so you've seen that you've got 6 and 6, 1 and 1, minus 2, minus 2. So you can kind of use that to reassure yourself you've got them right. Okay, so then let's plot those points. Minus 3, 6. Minus 3, 6 is there. Minus 2, 1. That's there. Minus 1, minus 2 down there. 0, minus 3. Okay, and then we've got 1, minus 2. We're going to start going back up again. And then 2, 1. And then finally 3, 6. Okay, so they're all the points. That's going to give us 1 or 2 of the marks, but to get the last mark, we're going to have to join them up with a nice smooth curve. Okay, so this is the bit of the tricky bit, guys. Now, if you struggle with drawing these, you can move your paper around. Okay, sometimes because of the way your wrist bends, it's easy to turn it in a way that your wrist goes. So if you kind of draw it from the inside of the curve, you might find it easier. Right, important things to note is that parabolas don't have pointy bottoms. They're nice. It should be a nice smooth curve. You'll lose marks if you feather or if you miss the points that you've actually marked. So if I draw my line and actually don't actually go through the points that I marked, then I'm going to lose a mark. If I have like feathering like this and multiple lines, that can lose you a mark as well. Okay, but I think that's all right. I think I'll get the marks for that one. Use your graph to solve x squared minus 3 is equal to 2. Well, this is the graph y is equal to x squared minus 3. Now, if I draw the graph y is equal to 2 on top of that, which is a horizontal line passing through y is equal to 2, then where my two lines cross should be the solution to that equation then. So if I draw my line like this, then you can see that they intersect here and here. Okay, so I just need to read those values off actually. Let me just get the ruler out. Just draw lines down to the axes maybe to make it nice and clear. So one of my solutions is going to be there, and one of my solutions is going to be there. Okay, so then it's just a matter of reading those off the x-axis then to answer the question. So x is, what's that, about 2.2? Or x is the other one. That's going to be minus 2.2. Question 22. A journalist is going to do a survey to find out whether people aged 15 or less spend more time playing computer games than people aged more than 15. The journalist says that their sample will be the first 20 people leaving a particular shop after 9 AM next Monday. Give one reason why the journalist sample is unlikely to give reliable information. Well, what happens after 9 AM every Monday morning? Well, most mornings, school kids are in school, aren't they? So the only people you're going to see coming out of a shop are people who are skiving school. Hope that isn't you. Or it's going to be some old grandma or older person who isn't working. So yeah, you're picking from a very particular group of people who aren't working or who have retired. You're not going to be finding school kids coming out of shops at 9 AM, I hope. Okay, so give one reason why the journalist sample is unlikely to give reliable information. Most people will be at work or school after 9 a.m. on Monday. So sample unlikely to contain a broad range of ages. Right, so part 2 or part B says make 3 suggestions to help the journalist obtain a sample that may give a more reliable information. Well, to be more reliable, I'm just going to say first off, I think the sample size is a bit small. So increase sample size. That would improve on the accuracy. My next suggestion would be to vary the location and time of interviews. And then finally, make sure you get equal numbers of older and younger people. Okay, so yeah, so you've got a broad range of people to compare. Okay, I think that will do. Let's move on. Question 23. The diagram shows a straight line crossing 2 parallel lines. And you've got a number of angles given here algebraically. Now find the value of y you must show you're working. Okay. Well, I'm going to start off by using some properties of parallel lines. This angle here and this angle here have a special name and a special relation, don't they? Do you know what it is? They're called corresponding angles, aren't they? So I'm going to start with that. I'm going to say corresponding angles because I need to show my working and my method. So corresponding angles, so that means that 2x plus 30 must be equal to, so they are equal, aren't they? Corresponding angles are equal, so 2x plus 30 must be equal to x plus 85. Okay, so you can see I've got a linear equation now in x, which I can go on to solve. Taking x away from both sides to start with, that's going to give me x plus 30 is equal to 85. And then subtract 35 from both, subtract 30 from both sides. That's going to leave me with x is equal to 55 then, isn't it? Okay, now I know what x is, I can look at finding y, because I can see that these two angles down here lie in a straight line. So I can say that angles on a straight line sum to 180 degrees, and that means that my x plus 85 over there plus my y must be equal to 180 degrees. Okay, but I know that x is 55 now, don't I? So subbing that in, so that means 55 plus 85 plus y is 180. And what is 55 plus 85? Well, 85 plus 5 is 90 plus 50, that's 140, isn't it? So 140 plus y is 180. And then simply taking 140 away from both sides, that will cancel, leaving you with y on the left. And then 180 take away 140, that gives me 40 degrees. So y is 40 degrees, and job done and paper done. We are out. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.